The future of agriculture is digital, with the help of Fraunhofer. The agricultural sector faces greater and increasing challenges. Environmental protection must be integrated when increasing productivity to provide food for a growing world population. Within CONIAC, short for Fraunhofer's Cognitive Agriculture Lighthouse Project, 8 Fraunhofer institutes cooperated to develop technologies and solutions that make farming more sustainable and efficient, and that support stakeholders from the agricultural sector in managing the digital future. One of the research project's key elements was the creation of a shared digital ecosystem and frameworks for an agricultural data space, referred to as ADS. ADS integrates existing solutions, systems and platforms and dynamically expands when including new components that can be individually combined and applied. Digital twins for agricultural resources such as field sections are stored in data hubs. Through this approach, all data collected within the individual production processes can be used by farmers and also shared with guaranteed protection of data and proprietary rights. The basis for agricultural work is an understanding of cause-effect relationships. To achieve this, it is becoming more and more important to acquire comprehensive data. Within the CONIAC project, Fraunhofer has developed new sensor systems that can record plant and soil parameters which had not been measurable until now. Soil compaction, caused among others by tillage with heavy machinery, makes the ground less permeable for roots and in turn lowers its capacity to absorb and store water and nutrients. Thanks to a mobile sensor platform that uses seismic measuring procedures, it is now possible to determine the soil density at different depths. Immediately after the measuring procedure has been completed, targeted actions for soil improvement can be derived from the results. For example, steps for minimally invasive soil loosening. Precise information about nitrogen levels in the soil contribute to the targeted use of fertilizers and a reduction of climate-damaging nitrous oxide emissions. As a result, soil and water are protected, all while saving money. A mobile nitrous oxide sensor helps detect emission levels by collecting the nitrous oxide that escapes from the ground in a bell jar. A pump then transports it into a measuring cell in which a laser determines the gas density. Sensor systems that execute their work on the ground, as well as airborne drones, allow the continuous, non-invasive and comprehensive detection of soil and plant states. Thanks to multi- and hyperspectral sensors, these states can then be mapped to precision in the centimeter range. This allows to monitor the nutritional supply of plants and soil, detect the spread of diseases in an early state, distinguish agricultural crops from weeds for targeted weed removal, and more. With the help of artificial intelligence, the data is processed and offered to farmers for further use within ADS. Due to increasingly strict legal requirements and rapid technological innovation, the complexity of agricultural processes is constantly growing. Within the CONIAC project, Fraunhofer has developed intelligent services that give customized support for farmers and contribute to more efficient work processes. Data and other parameters collected in the field can be visualized and analyzed with the help of a new software. In combination with plant growth models, exact predictions for crop yields and harvest dates can be calculated. This provides important decision-making support for the optimal use of fertilizer in terms of timing and surface area. If an agricultural contractor employed for the harvest season is granted access to the predicted plant maturity levels, a Fraunhofer-developed service optimizes the contractor's logistics by providing forward-looking machine allotment. This way, high yields can be generated throughout the entire harvest campaign and transport costs can be reduced. The mapping of nutrient flows in agricultural enterprises is another complex task. With the help of an additional app, relevant points within the nutrient cycle are recorded and stored in ADS. Continuously verified sensor data complements known metrics and allows the specific treatment of field sections. The sensor data acquired in the process is automatically documented. In order to meet the requirements of sustainable management and respond to the growing shortage of skilled labor, new approaches must be taken. With the attempt of realizing fully electrified autonomous fieldwork and drastically reducing the use of plant protection agents, the Cognac project also generated field robots for different application purposes. CURT is a lightweight, intelligent robot solution that navigates fields autonomously to detect weeds. Using specifically designed tools, CURT mechanically removes weeds in a targeted manner, even in close proximity to crops. Thanks to its robust environment perception system, it is able to execute turning maneuvers independently. Through the fusion of sensor data, its autonomy remains intact, even in case of temporary loss of GPS connectivity. CURT will gradually be improved and assigned to agricultural operations. With CERES, researchers created a robot that is robust, powerful, fully electric, and has already been tested in the field. CERES is both a platform used for different Cognac sensor applications and a carrier vehicle for agricultural machines. The so-called Navibox and the Helios open-source control tower software ensure the robot's efficient operation. Both systems are already successfully being used for the operation of mobile work machines and utility vehicles respectively. Through cutting-edge algorithms for path planning and the automatic detection of plant rows, fully automated mission creation and autonomous navigation are made possible. A charging trailer parked alongside the field and equipped with an automated contact system provides around-the-clock, decentralized high-power energy supply for one or several robots at a time, thus allowing continuous operation day and night. Cognac allows Fraunhofer to combine forward-thinking solutions from the realms of sensor systems, software-based intelligent applications, and robotics. All this is achieved within the agricultural data space, a safe and interoperable digital ecosystem. The Fraunhofer Gesellschaft, with its interdisciplinary institutes, is your preferred partner for the successful digitalization of agriculture.